Hey guys, welcome back to Click Academics. In today's video, I'm going to be proving that 2 plus 2 is actually equal to 5. And make sure to stick until the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 2 plus 2 is equal to 5. So, let's first start with 0 is equal to 0. This is a true statement, right? 0 is equal to 0 because any number is equal to itself. So on my left-hand side here, I'm going to rewrite 0 as 20 minus 20. And 20 minus 20 is 0. So this is right. I'm not doing anything that is illegal here. And for my right-hand side, I'm going to rewrite 0 as 25 minus 25, which is also equal to 0. So I'm not going out of the rules or anything. Now, 20, this is the same thing as 4 times 5. So now I have 4 times 5 minus 4 times 5 is equal to 25. This is 5 times 5 minus 5 times 5. So again, I'm not going past the rules or anything. 20 is equal to 4 times 5, so I simply substitute in 4 times 5 for 20, and same thing with 25. 25 is equal to 5 times 5, so I simply substitute in 5 times 5 for 25. Now, this is the same thing as 4 times 5 minus 5. All I did was I factored out 4 from this because both terms were being multiplied by 4. And now this is the same thing as 5 times 5 minus 5. All I did was I factored out 5 from this because 5 is being multiplied by both terms. So now what I'm going to do is I'm going to divide both sides by 5 minus 5. So then these two cancel out, and these two cancel out. And now I'm left with 4 is equal to 5. Now 4, this is the same thing as 2 plus 2. So I have 2 plus 2 is equal to 5. And there it is. I just proved that 2 plus 2 equals 5. However, this is actually wrong. And somewhere in solving this, I actually made a mistake that you cannot do in mathematics. So as you can see here, I had 4 times 5 minus 5 is equal to 5 times 5 minus 5. Now 5 minus 5, this is actually equal to 0. So now I have 4 times 0 is equal to 5 times 0. And what I did was I divided by 5 minus 5 on both sides. And if you guys already didn't know, dividing by 0 is not defined because anything divided by 0, well, as you see, 4 divided by 0, if we tried to do this, 0 times what equals 4? Well, nothing, because you can't multiply anything by 0 to get 4. 0 times anything is 0. So dividing anything by 0 is undefined. So when I divided both sides by 5 minus 5, I really divided both sides by 0. And now 4 times 0. So now if we do this, 4 times 0 divided by 0, this is 0 over 0 is equal to 0 over 0, and 0 divided by 0 is undefined. So this, you can't do this. So why dividing by 0 it can lead to weird results. So I have 2 to the power of 24 minus 1. So 2 to the power of 24, well 24 I can rewrite as 12 times 2. So now I have 2 to the power of 12 times 2 minus 1. Now if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. So 2 to the power of 12 times 2, I can rewrite as 2 to the power of 12 to the power of 2 minus 1. Now, let's first go ahead and find the exact value of 2 to the power of 12. Well, 2 to the power of 10, we know this is 1024. And 2 to the power of 12, this is the same thing as 2 to the power of 10 plus 2. So now if I have something in the form a to the power of m plus n, this is the same thing as a to the power of m times a to the power of n. So in this case, 2 to the power of 10 plus 2, this is equal to 2 to the power of 10 times 2 to the power of 2. Now, 2 to the power of 10 times 2 to the power of 2, well, 2 to the power of 10, we know this is 1024, and 2 to the power of 2, that's 4. So I have 1024 times 4, so if I now do this, 4 times 4 is 16, 4 times 2 is 8, 8 plus 1 is 9, 4 times 0 is 0, and 4 times 1 is 4. So I have 4096. So now this is the same thing as 4096 squared minus 1. Now 4096 we can rewrite as 4100 minus 4 squared minus 1. And now if I have something in the form a minus b squared, this is the same thing as a squared minus 2ab plus b squared. So in this case, a is equal to 4100 and b is equal to 4. So now I have 4100 squared minus 2 times 4100 times 4 plus 4 squared. And we can't forget the minus 1 at the end. So now this is equal to 4100 squared minus 8 times 4100, because 4 times 2 is 8, plus 4 squared, which is 16, minus 1. Now 16 minus 1 is 15, so now I have 4100 squared minus, well, 8 times 4100, that's going to equal 32,800, plus 16 minus 1 is 15. And now 4100 squared, this is the same thing as 1,681,000. Now I have this minus 32,800 plus 15. And now 1,681,000 minus 32,800, that's going to equal 1,677,000. Sorry, I made a mistake. This is actually 16,810,000. So now it's equal to 16,777,200. Now I have this plus 15. So now if I add these two, I get 16,777,215. So this is my answer. Alright, so I have x to the power of 3 minus 27 is equal to 0. Now I'm trying to find the value of x here. So for my solution, I first start with x to the power of 3 minus 27 is equal to 0. Now, 27, this is the same thing as 3 to the power of 3. So now if I substitute in 3 to the power of 3 for 27, I get x to the power of 3 minus 3 to the power of 3 is equal to 0. Now, if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So in this case, a is equal to x and b is equal to 3. So now I have x minus 3 times x squared plus 3x plus 3 squared. That's equal to x minus 3 times x squared plus 3x plus 3 squared, which is 9. And remember, this is equal to 0. So now this gives me two equations. I have x minus 3 is equal to 0, and I also have x squared plus 3x plus 9 is equal to 0. So for x minus 3 equals 0, all I have to do is add 3 on both sides. These two cancel out, and I'm left with x is equal to 3. So this is one solution. Now for x squared plus 3x plus 9 equals 0, I'm going to be using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now in this case, a is equal to 1, b is equal to 3, and c is equal to 9. So now I have x is equal to negative b, so negative 3, plus or minus the square root of b squared. So 3 squared minus 4 times a, which is 1, times c, which is 9, all over 2a, so 2 times 1. So now I have x equal to negative 3 plus or minus the square root of 3 squared, which is 9, minus 4 times 1 is 4, 4 times 9 is 36, all over 2 times 1, which is 2. And now I have x equal to negative 3 plus or minus the square root of 9 minus 36. That's equal to negative 27 over 2. And now negative 27, the square root of negative 27, I can rewrite as the square root of 27 times the square root of negative 1. And if you guys already didn't know, the square root of negative 1, this is actually equal to the imaginary number I. So now, if I replace I with the square root of 27, or sorry, the square root of negative 1, I get negative 3 plus or minus the square root of 27, I over 2. So these are two other solutions to this problem. So now my first solution, this is 3. My second solution, this is negative 3 plus the square root of 27i over 2. And my third solution is negative 3 minus the square root of 27i over 2. So these are my three solutions to this problem.